So, two terms, matter versus energy. Matter versus energy. So, the biggest takeaway that I want you to take from this lesson today is that matter is not energy. Matter is not energy. So, matter is defined as anything that takes up space and has mass. The mass being weight. Anything that takes up space and has mass, we call matter. Energy, we describe as something that provides the power to do work. That work can be something that we visibly see, like pushing a table, but it can also be things that we don't see, like a chemical reaction. There's energy that's needed. Okay. So with those in mind, we say that matter can be moved or rearranged by energy, and it can also store energy. So matter can store energy, and it can be moved or rearranged by energy. And that energy affects matter, and energy can be transformed into different types of energy. Okay. So, there are two different types of energy. So we're going to need to know. So two types of energy. We've got kinetic, and we have potential. So kinetic and potential energy are the two types of energy. And kinetic energy is simply energy associated with movement. Energy associated with movement. Potential energy refers to energy that is stored for a later use. Energy that is stored. And within each of these categories, we've got a bunch of different examples of kinetic and potential energy. So some of these you've probably heard of. Probably the most common one, something like thermal energy. When something's warmer, this is heat. When something's warmer, has more thermal energy, it means that the molecules are moving more. As opposed to something that's colder, like ice, the molecules are slowly moving, if not almost still. Thermal energy Another common example that you see is sound energy. Sound causes molecules to move as sound waves move through, say, air or another medium. Sound energy, we also have light energy, or for our case, solar energy. We've got electrical energy. Electrons moving in a current allows energy to power things like lights. And then lastly, mechanical energy. Right, mechanical energy is something like at a large scale, like a machine that's working in response to energy, a muscle that's contracting. That's all mechanical energy. Potential energy, though, there's only two major ones. The two major ones are gravitational, right? That is potential energy that's due to gravity. If you hold a ball above the ground, it has potential energy because of the gravity that will pull it down if you release that ball. The other example that we're going to use a lot in this unit is chemical energy. That is potential energy that's stored in a molecule. Think like gasoline. So gasoline is a chemical potential energy. It's got specific molecules that store energy. Okay. So with those two types in mind, kinetic and potential, what we can do is we can actually describe different scenarios. Let me tell you what I mean. So take a TV, for example. A TV that's plugged into the wall. There are lots of different types of energy that are involved in, say, watching TV. So if you think about a TV that's plugged in, so it's a super old TV. Right, so if I have a TV that's plugged into the wall, beautiful drawing here. What we have here is that what comes out of a TV are different types of kinetic energy. Things that come out of a TV are sound, light, and thermal. You leave the TV on for a while, you probably notice it gets a little bit warm to the touch. And what we know is that here, electrical kinetic energy is powering the TV. But if you notice that electrical energy, it changes form into three different types. If you trace this back further, that electrical energy actually started in fossil fuels. Fossil fuels are chemical potential energy. We're talking about mainly coal here when we talk about electricity. If you go to a power plant, the whole purpose of a power plant is to transform that chemical potential energy into a usable form, electricity. Right, so we're going from potential energy to electrical energy to sound, light, and thermal energy. Okay. Now what's important here is that energy follows something called the law of conservation. So the law of conservation it states that energy and matter cannot be created or destroyed. Energy can only be transformed and matter can only be rearranged or moved. Right? Which would mean that the energy that's stored here should be equivalent to the amount of energy that's put out in these three distinct forms. That's what the law of conservation is saying.